a few things that I have come across in my research over the years seem to have similarities, and I think are worth exploring further. So this is a note on those things, which I have before spoken about in some other platforms, but I'll just put this on, make a note on a video platform. And is that a baby rabbit or a mouse, or just a big rat? All right, it's a baby rabbit. So there are three different, I suppose, they are theories. I don't know. Wow, there are 3 little baby rabbits, and they are chasing each other around a bush. Pretty cute. So, well, let's see. Where'd that little bugger go? There's one right there. Right? I almost thought there was a little rat. But coming to the light. Hello, little bunny. Hello, are you coming this way? What are you doing? Is he gonna go play with his little friends? Probably siblings, right? Probably some bunny siblings chasing each other over there. Oh, there's another one. It's creeping. It's creeping up on him. Oh, there's two. Oh, there's all 3 of them now. Whoa, there's 4 of them. All right, well, I didn't necessarily want to speak about rabbits, but they are adorable. So the 3 similarities I found are, one of the ones that are most popular that people might know about in quantum physics is string theory. And string theory, just the basics here are that all of the particles that make up existence, meaning particles as in subatomic particles, so sub meaning below, right? Below the size of, we're talking about things like electrons and neutrons and protons, which are hadrons, as they're called, and are made up of quarks. You know, the 2 up quarks and the 1 down quark in the proton, and the 2 down quarks and the 1 up quark in the neutron, and then they have all these different quarks like strange and charm, and top and bottom quarks, and you know, there's color charge and electric charge, which color charge is not really what a charge necessarily, it's just a relationship. But the point about string theory is that all of those particles, all of the indivisible particles, because it was thought that the atom could not be cut or divided, right? Atom. A meaning not, right? Like if you're atypical, it means you're not typical. So atom, it's not cuttable, not dividable. And so all of the indivisible, the fundamental particles are made up of strings, which are either closed loops, meaning like a rubber band is closed, or an open-ended string, a rubber band perhaps that's cut. And the way that they vibrate, their particular frequency makes they are what then become the fundamental particles, the electrons, the quarks, and even the bosons, which I think now that they've discovered the Higgs boson, there's 5 of them. So you get the Higgs boson, and then you've got the W and the Z boson that are in the weak nuclear force, and then there's of course the photon, and then the gluons are bosons as well, named after an Indian physicist named Bose. But so that's the thing. The all of the fundamental particles are made out of particularly specific vibrations of strings. That's the essence. That's really the very bare bones basic of string theory. String theory talks about a lot of other things. For example, string theorists go into how it's possible that the Big Bang started in this universe because of a membrane, shortened to be called brane, B-R-A-N-E, in which these different branes contain different universes. So it's another sort of a multiverse theory, and that when these branes come close to each other and they touch, at that point where they contact in that universe, from there is the point where a Big Bang happens. And it doesn't happen too often, apparently, at least in human time, because we've been here for about 14 billion years, a little less, something like that. So, and that's what happened before the Big Bang. That's one of the causes of the Big Bang. But that's not the point. The thing to focus on here, what is similar to some of these other theories that I've seen that are from different disciplines, if I may say so, is the fact that matter comes from vibration, from frequency. And another one of them, which I'll go in this descending order into what would seem more obscure or more fringe. The next one is from Dr. Paul A. LaViolette, PhD, who I first came into contact with his work from a book that I saw because it had a fantastic title, which was Secrets of Anti-Gravity Propulsion. And he has a theory called subquantum kinetics. And his subquantum kinetics is composed of these also fundamental elements of particles, which he calls etherons, because he's paying homage to the ether theories before that. People like James Clerk Maxwell was attempting to elucidate, like in the end of his treatise on electricity and magnetism, he said so in the first volume 1 of that. At the end of it, he very clearly says the thing that I've been trying to elucidate this whole time is that there's some kind of medium in ether in which these particles, the electromagnetic force, is being propagated amongst or along and through. And interestingly enough, Paul Ehrlich, his main propositions through subquantum kinetics are also dealing with electricity and magnetism. In fact, his anti-gravity propulsion deals with that, and using capacitors and charging these capacitors to get a gravitational effect, which I wouldn't necessarily say it's anti-gravity, it's gravity manipulation. That's my position, because what we know normally as gravity is a gravity well, and things fall into a well. His subquantum kinetic theory takes not only there being a gravity well, but then making a gravity hill. So imagine if a hill were to pop up underneath you, it would push you up, right? Like in the tectonic plates, like if a mountain, like when the plates of the earth push together, they make mountains by pushing upwards. So if you were standing on that, right, it would push you up. It would make a hill first and then a mountain. So sort of gravity hill is like it pushes you away from massive objects rather than having you fall into them. Again, though, that's not the point. I tend to geek out and get distracted on these things when my free association in the mind. But the point is, again, that number one, string theory, different vibrating strings, the way their specific frequencies create. If one specific frequency creates an electron, another frequency creates a quark, another frequency creates so on and so forth, right? The fundamental particles. And so in Paul Ehrlich's subquantum kinetics, the etherons, there's something called the model G, in which these different etherons, the way that they interact, there's a specific sequence, and the way that they interact then also in a similar way, they tend to, out of what seems like nothing, their information forms the subatomic particles. And so it's another way, it's another frequency, because the way that the etherons interact is sort of like an algorithm. You know, one Y etheron, another etheron, I forget, I think there's X, Y, and maybe a G etherons. But just the way that the order that they go, the algorithm, meaning the order that they interact with each other. So it's like a frequency. You know, for example, if it goes X, Y, G, and in a certain rhythm, in a certain flow, in a certain rate, then I have to look at that again, because it's actually a fascinating theory. I got to get another edition of his book, Subquantum Kinetics, because I lost my copy. I had a digital copy of it, but I should buy a physical copy. But again, frequency creates the fundamental particles. And then an even more obscure one, that I learned about from a guy online who I have long since stopped watching his stuff, because it became very apparent that he's full of shit, is a guy named Morg, which, if you want to be entertained with some of the stuff he says, he's a fascinating guy. I mean, he's talented, he's an okay communicator. He does great production. I mean, he knows what he's doing as far as, you know, creating a business online with Patreon and that stuff like that. So I'll give him that. I mean, he's not terrible at everything. But he turned me on to something called ontological mathematics. And as you can see, there's these, you know, highfalutin, convoluted names like subquantum kinetics and ontological mathematics, right? It just sounds fun because they sound all complicated, so it sounds cool, right? But some of his followers, and I need to find those videos because they're actually really good, they combine mathematics and philosophy, which I think is an excellent combination. It's actually one of the combinations, a fantastic combination that I feel is amazing, because it's what I use in my metaphysics. And my metaphysics is META. I hijack the word meta, which means above or beyond. So metaphysics is above or beyond physics, right? And I hijacked it and turned it into mathematical, experimental, theoretical, and applied physics, implying or explicating that I believe that people should have a foundation in those things before they start making statements saying that physics and science doesn't reach into some of the phenomena that are supposedly in the realm only of metaphysics, because science does do that, and that's why there's a lot of chaos and argument sometimes amongst scientists, specifically physicists, with all these different theories. Like there's theories the Big Bang is the beginning and that's when time started, but then you got string theorists saying no, it possibly couldn't be because there's these brains and there's time before that, and these brains are different universes, and then there's the many worlds hypothesis and the multiverse, things like that, and then there's quantum loop gravity, and so there's all these different things talking about what came before the Big Bang, and that time didn't start there, and so, but the thing about again, getting back on track here, is that the similarities between string theory, subquantum kinetics, and now ontological mathematics, which is not originated by this guy Morg, it's just that he pointed me in the right direction to people like Mike Hockney, and if you do a search online, you'll find some really great resources for ontological mathematics. It's a fascinating subject. But one of the followers of Morg, they did some videos. The channel was called OntMath, short for ontological mathematics. I looked for it again, I couldn't find it, but I'm going to see if I can find it again. They did an excellent series of videos in which they went through philosophy and then some basic math and showed basically, again, frequency, sine and cosine waves. They also involved Euler's number from Leonhard Euler and Fourier transforms, and showed how different frequencies, standing sine waves and cosine waves, how those specific frequencies of those things also give rise to the fundamental particles of reality. So those three things right there, I'm going to make a very concentrated effort to look at them and devise my own highfalutin, convoluted theory out of it, but hopefully simplifying, because I'm a very simple person. I don't like when things get too out of control. It starts getting too much. It's already enough looking at all these mathematical equations and things like that. So, but those are some very interesting things, and what it does suggest to me is that there may be, my opinion is that it lends some merit, and I say opinion, but my educated guess based on researching these three things indicates to me that there is some merit to the underlying vibrational genesis of our cosmos, of our existence, of our reality. And that stretches into some things that are definitely in the realm of metaphysics. Specifically, if you look into some of the ancient Hindu philosophies, and the sound Om and vibration and sound being everything. And there was a time when I actually thought that you couldn't have sound in space, but there was a time closer to the Big Bang when conditions were so dense that we had something called acoustic baryonic or baryonic acoustic oscillations. Is that right? Is it baryonic acoustic oscillations? Yeah, I believe that's the order. It's either no, it's ABC. No, or ABO. Is it acoustic baryonic oscillations or baryonic acoustic oscillations? Either way, it's the same thing. It's that there were sound, something that was very, very similar to, if not exactly like, sound waves that happened in the earlier universe in space. So before there was, like what we know it now by sound waves going through solid objects like wood and water. Well, water's a liquid, and then the gases like the oxygen and nitrogen that makes up our air. So there is some interesting things to think about the vibrational genesis of our reality. So that's really what this is all about, the vibrational genesis of our reality. And 3 places to look for me right now I think is going to be fun is string theory, which is more mainstream physics, and then subquantum kinetics as proposed by Paul A. LaViolette, PhD, and then ontological mathematics and their specific rendering of Euler's number and Fourier transforms, showing how you can get from information, symmetrical information, that then becomes decoupled and becomes asymmetric, and then those specific vibrations give rise to our physical reality. So that would be something interesting to look at. So string theory, subquantum kinetics, and then ontological mathematics. That, I'll call this the vibrational genesis of reality, VGR.